Hello, folks. All right, so in today's lesson, we're going to look at hyperbolic functions. So hyperbolic functions are functions of the form y is equals to 1 over x. The functions of the general form y is equals to a over x plus q are called hyperbolic functions. Now let's look at an example, a worked example, so that we can see how this thing actually looks like. So let's try and plot and graph this function. Okay, all right. So if you substitute those points, all right, and you get your output values, all right, and then these are the points you're going to get, and then you plot them. This is the type of graph you're going to get. And some few things. Notice that this graph doesn't touch the y-axis. And because the graph doesn't touch the y-axis, we say that the y-axis is your asymptote. Also, the graph doesn't touch the x-axis. So this means that the x-axis is also your asymptote. So the y-axis is what you call your vertical asymptote. The x-axis is your horizontal asymptote. For x is equal to 0, the function h is undefined. This is called discontinuity at x is equals to 0. Now y is equal to 1 over x. Therefore, we can write that x times y is equals to 1. Since the product of two positive numbers and the product of two negative numbers can be equals to 1, the graph lies in the first and third quadrant. Okay. Now determine the asymptote. As the value of x gets larger, the value of h of x gets closer to 0, but does not equals to 0. This is the horizontal asymptote. The line y equals to 0. The same happens in the third quadrant. As x gets smaller, h of x also approaches the negative x-axis asymptotically. We also notice that there is a vertical asymptote. The line x is equals to 0. As x gets closer to 0, h of x approaches the y-axis asymptotically. All right. Then the domain is x is the element of real numbers, but x is not equals to 0. And why are we saying that? It's because, remember we said at x is equals to 0, which is the y-axis. That's where we find our asymptote. And because that is where we find our asymptote, that value cannot be part of the domain because it will actually make our graph undefined or our function. From the graph, we see that y is defined for all values except 0. The range, y is the element of real numbers, but y is not equals to 0. Now, we also have the line of symmetry. The graph of h of x has two axes of symmetry. The lines y is equals to x and y is equals to negative x. About these two lines, one half of the hyperbola is a mirror image of the other half. Okay. Now let's look at the effect of Q. The effect of Q is called a vertical shift because all points are moved the same distance in the same direction. It slides the entire graph up or down. For Q greater than 0, the graph of f of x is shifted vertically upwards by q units. For Q less than 0, the graph of f of x is shifted vertically downwards by q units. The horizontal asymptote is the line y is equals to q. And the vertical asymptote is always the y-axis. The line x is equals to 0. Now let's look at the effect of A. The sign of A determines the shape of the graph. If A is positive, the graph of f of x lies in the first and third quadrants. For A greater than 0, the graph of f of x will be further away from the axis than y is equal to 1 over x. For A between 1 and 0 exclusive, as A tends to 0, the graph moves closer to the axis than y is equal to 1 over x. If A is negative, the graph of f of x lies in the second and fourth quadrant. For A less than -1, the graph of f of x will be further away from the axis than y is equal to -1 over x. For A between 0 and -1, as A tends to 0, the graph moves closer to the axis than y equals to -1 over x. And you can see here that since A is 0, our graph is in the second and fourth quadrant. If A is positive, it's in the first and third quadrant. Now, since Q is positive here, your graph has shifted upwards Q units, meaning that the asymptote, this horizontal asymptote, is going to be at Q. So let's say, for example, Q was 5. So your horizontal asymptote is going to be y is equals to 5. When Q is 0, notice that your horizontal asymptote is the line y is equals to 0, which is the x-axis. When Q is negative, your graph shifts downward Q units. Now we said that the standard form of a hyperbola is the equation y is equals to a over x plus q. So to get your domain, for y is equals to a over x plus q, the function is undefined for x is equals to 0. Therefore, the domain is x is the element of real numbers, but x is not equals to 0. We see that y is equals to a over x plus q can be written as, right? So we take q to the left, becomes negative. Then if x is not equals to 0, then y minus q multiplied by x is equals to a. So if we divide both sides by y minus q, we get a over y minus q. This shows that the function is undefined only at y is equals to q. Therefore, the range is y is the element of real numbers, but y is not equals to q. Sharp. So let's say we're given this. Determine the domain and range of the function. Notice, folks, that the domain is x is the element of real numbers, but x is not equals to 0 because g of x is undefined only at x is equals to 0. If we substitute 0 here, you'll get 2 over 0, which is undefined. Then for the range, we see that g of x is undefined only at y is equals to 2. Therefore, the range is y is the element of real numbers, but y is not equals to 2. This 2. Then now let's look at our intercepts. The y-intercept is where x is equals to 0, right? In this case, you can see that if you substitute 0, we're going to get something undefined. Therefore, there's no y-intercept here. Then for x-intercept, we let y equals to 0. If we do that, therefore we get x is equals to -1. This gives us the point -1 is to 0. And remember, your asymptote, we said there are two asymptotes for the function. If the horizontal asymptote, which is the line y is equals to q, and the vertical asymptote is always the y-axis. The line x is equals to 0. Now the axis of symmetry, these are two lines about which a hyperbola is symmetrical. First one is y is equals to x plus q, and y is equals to negative x plus q. Now, if you want to sketch your hyperbola, you need these four things: the sine of A, y-intercept, x-intercept, and your asymptotes, and that's all. Let's say, for example, you want to sketch this one, right? First thing first is to notice that this 2, which is A, is positive. Therefore, your graph is going to lie in the first and third quadrant. Then you calculate your y-intercept by letting x equals to 0. So you can see that we don't have any y-intercept. Then the x-intercept, we make y equals to 0. So this gives us the point negative 1 is to 0. For the horizontal asymptote, we get the line y equals to 2. And the vertical asymptote is the line x is equals to 0. Then from there, we can sketch our graph. This is the graph. You can see that the horizontal asymptote is at 2, which is this plus 2 here. No. And there is no y-intercept because the y-axis is the asymptote. Now the domain is x, the element of real numbers, but x is not equals to 0. The range, y is the element of real numbers, but y is not equals to 2. Let's sketch this one. For this one, you can see that A is negative. So your graph will lie at the second and fourth quadrant. Yeah. And from there, try and find your y-intercept by letting x equals to 0. If you do that, you can see that you get something undefined, which means that we don't have any y-intercept. Then for the x-intercept, we let y equals to 0. And if we do that, this gives us the point 4/7 is to 0. Yeah. And from that, we determine the asymptote. So the asymptote, the horizontal asymptote is the line y equals to 7, and the vertical asymptote is the line x is equals to 0. And from there, you can draw your graph. Now you can see that this plus 7 is our y, is our horizontal asymptote. And we do have the x-intercept at 4/7 is to 0. Domain again, x is the element of real numbers, but x is not equals to 0. The range, y, the element of real numbers, but y is not equals to 7. Axis of symmetry in this case, y is equals to x plus 7. Remember, plus q. So in this case, q is 7. So y is equals to x plus 7. And y equals to negative x plus 7. All right, folks, please pause the video and try this exercise. All right, folks. So for the first question, right, this is what we're supposed to do. So notice that from the graph, we can see that Q is positive 2. Then from there, you can use any other point that was given. So in this case, this point was given. You can use it to try and find A. So if you substitute it in, then you should get that A is equals to -1. Therefore, the equation is y is equals to -1 over x plus 2. Number 2, Q is 3. From the graph, then if you substitute that other point that was given, A is equals to -2. Therefore, the equation is y is equals to -2 over x plus 3. Then for number 3, determine the location of the y-intercept. We don't have any y-intercept, right? And B, x-intercept is -3 over 2, is 20. Number 4, there's no y-intercept again. And B, x-intercept is -1. Then number 5, we're given these graphs. Then you have to choose which one is which. So for A is h of x. And B is g of x. C, -2 over x. Then D, y equals to 8 over x. Then 6, A is negative, and so the function lies in the second and fourth quadrant. So this is a function. Does the point -2 lie on the graph? Substitute. Then we can see that this satisfies the equation. Therefore, the point does lie on the graph. Then C, if the x value of a point on the graph is 0 is to 0.25, which is 1 over 4, what is the corresponding y value? Then the corresponding y value is -2, 4, -24. Now, what happens to the y values as the x values become very large? The y values decrease as the x values become very large. The larger the denominator, the smaller the result of the fraction. Then the E, the graph is not vertically or horizontally shifted. Therefore, the asymptotes are y is equals to 0 and x is equals to 0. With the line y equals to -x as the line of symmetry, what is the point symmetrical to -2 to 3? Across the line of symmetry, the point symmetrical to -2 to 3 is -3:2. So to get that point, you just swap your coordinates. The one that was x becomes y, the one that was y, it becomes x. but you also do what? Yeah. Then number 7, that's your graph for 7a. How would the graph of g of x equals to 8 over x plus 3 compare with this one? It's going to be shifted 3 units upwards. There would be the same shape, but the asymptote of g of x would be y is equals to 3 instead of y equals to 0. For h of x, the axis of symmetry would be y is equals to negative x plus 3 instead of y equals to negative x. Draw the graph of y equals to 8 over x plus 3 on the same set of axes. Now, this is how it would look like. All right, so for number 8, sketch the functions given and describe the transformation performed on the first function to obtain the second function. Okay, there we go. Y is equals to 3 over x blue, then y equals to 1 over x black. This is a magnification by 3, by a factor of 3. Then B, these are your graphs. Y equals to 6 over x blue, y equals to 6 over x minus 1. It's this one, the black one. And notice that now the asymptote has changed. The horizontal asymptote is now at negative 1. Then C, these are graphs. Y is equals to 5 over x and y equals to negative 5 over x. This is a reflection on the x-axis or reflection on the y-axis. And D, that's how D looks like. This is reduction by 2. All right, folks, thank you so much. I'll see you in the next video when we look at exponential graphs. Thank you.